Very good afternoon. See, I'm starting the session. Listen. So in the previous session, very clearly we discussed about indexes. The index main purpose is improving performance of data retrieval. So if we want to retrieve the data quickly from the table, we use this index concept. So how many types of indexes are there? Two types are there. One is B-tree index, another one is bitmap index. So B-tree index means B-tree will be created. Bitmap index means B-tree will not be created. If B-tree is created, we are calling that as B-tree index or normal index. If B-tree is not created, we are calling that as a bitmap index. So simple index means if index is created on one column, that is simple index. Composite index means if index is created on multiple columns, that is composite index. Unique index means the column which contains unique values. On that we create this index. So till here we discussed in the previous session. Next one is function based. Listen carefully here. What is this function based index? Listen. Function based index. So, see here. For example, if index is created based on function, based on built-in function. So many built-in functions are there. Oracle SQL is providing many built-in functions to us. If index is created based on built-in function or expression, if index is created based on built-in function or expression, then it is called function based index. So if index is created based on built-in function or expression, then it is called function based index. For example, see, listen carefully here. My requirement is I want to retrieve the data frequently based on the ename, employee name. I want to retrieve the data based on the employee name frequently. So we create index on ename column. So how can we create the index on ename column? Create index name on table name is emp1, column name is ename. Okay, now for example, I am writing like this. Select star from emp where ename equals to Alan I am writing. So now you tell me, is it perform table scan or index scan? Table scan or index scan? Okay. It will perform index scan, not table scan. Because if index is not created, if this index is not created, table scan it will perform. So we already created index, right? We already created index. So if index is created, it will perform index scan, not table scan. So it will perform index scan now. Okay. Now, but in real time, generally, we will not write like this. So how we write? If we know the exact case of ename, we write like this. So when we don't know the exact case So here ln we are specifying in the uppercase. If we know the exact case, we write like this. But in the real time, generally we will not write like this. Okay, when we don't know the exact case, for example, we don't know exact case whether the table data, whether employee names are in uppercase or lowercase, we don't know. We may specify lowercase like this. At that time, what we do, this employee name we convert to the lowercase and we compare with lowercase ln here. So if we retrieve data based on ename column, it is performing index scan, okay. But here we are using function here. Observe, if we use the function, again this index will not work. It will perform table scan only. It will perform table scan only. Now what we have to do, we have to create the index on this lower function. We have to create the index on this lower of ename. Okay. So why we are creating index on lower of ename? Because if we write ename equals to ln, our index is working. But if we write lower of ename, it is performing table scan. But in the real time, we use function only. So on this function, we have to create the index now. So what we write here, we write like this: create index. Index name I am giving as I6 on EMP1 of, okay, on which function we want to create the index? Lower function, lower of ename, on lower of ename. On lower of ename, we want to create the index. So this is called function based index. This one is called function based index because based on the function we are creating this index. So on lower function, we are creating the index. So on lower of ename, we are creating the index. So this is called function based index. Okay. Now observe here. After creating this function based index, if we submit this lower function, lower of ename equals to ln, now what it will perform? Again, it will perform index scan. Okay, once again I'm repeating, observe. So what is function based index? If index is created based on the built-in function or expression, we call that as the function based index. For example, our frequent operation is retrieving data based on employee name. So on employee name, we are creating the index. So in the where condition, if we write ename, it is performing index scan, okay, because we created index on ename. So our index is working. It is performing index scan. But in real time, we use functions like this. So we convert the employee name to the lowercase and we compare with lowercase name because we don't know the exact case here. When we don't know the exact case, we convert the column data to the lowercase and we compare with the lowercase data. So we created index on ename, but we didn't create index on lower of ename. That's why it is performing table scan only. Okay, if our index is not working, if we want to perform, if that has to perform index scan, we have to create index on lower of ename. So based on the function, we are creating this index. This is called function based index. After creating this function based index, in the where clause, if we use lower function, it performs the index scan. That's it. I'm showing it practically. Observe. Yesterday we created this EMP1 table. EMP1 table is having some data. Okay. Now, our requirement is frequently we want to retrieve the data based on ename. To see the execution plan, which command we have to set auto trace as on explain. Set auto trace on explain we have to write. I am retrieving data based on ename now. So select star from EMP where ename equals to ln I am writing. Observe here, is it performing table EMP1? Select star from EMP1 where ename equals to ln I am writing. So now is it perform table scan or index scan? table scan because we didn't create the index. So table scan it is performing. Observe here, complete table access. Table scan it is performing. Okay, now, so table scan it is performing and Allen recorded is displaying to us. Now, to improve the performance, what we are doing is we are creating index on ename column. So create index I5 on EMP1 of ename. So index is created. Now again we are submitting the same query. Now is it perform table scan or index scan? Index scan, because index is created on ename. Okay. So observe here, index range scan it is performing. Okay. I5 index. Based on this index, it is going to the table and it is identifying by using the row ID. Okay. Now, see, I am writing like this. Select star from EMP1. I don't know the exact case there. In the table, whether Allen data is in uppercase or lowercase, I don't know. So when we don't know the exact case, we write like this. We convert the column employee name to the lowercase and we compare with the lowercase data. With lowercase employee name, we are comparing. So we don't know the exact case here. So that's why we are converting this employee name column value to the lowercase and we are comparing with the lowercase name. Okay. So now, is it perform table scan or index scan? Table scan, because we created index on ename, but we didn't create index on lower of ename. Okay. So that's why it is performing table scan only. Observe. See here, table scan only it is performing. But mostly in real time, we use function only. We will not retrieve like this. Okay, like this ename equals to Allen, we will not retrieve like this in the real time. We use function only. So based on the function, we have to create the index now. So based on the function, if we want to create the index, so we write like this. Create index. Index name is I6 on EMP1 table. Okay, create index I6 on EMP1. Which function? Lower function. On lower of ename. On lower of ename, we are creating the index. Now, observe here, select star from EMP1, where lower of ename equals to Allen I am writing. Now, is it perform table scan or index scan? Index scan, because we created index on lower of ename. Okay, observe here, index range scan, it is performing. Okay, so that index name is what? I6. Just now we created this I6. This I6 is function based index. So you already know how to see the indexes information. To see all indexes information stored in which table? User indexes. So to get the index name, column name is index name, comma. To get the index type, column name is index type. So from which table? From user indexes we are retrieving. Okay, observe here. Observe. Just now we created I5 and I6. Okay. So I5 and I6 we created. Just observe I5 and I6 for them. See the index type here. See the index type. Okay. Sorry. I6 we created on function. I6 we created on lower of ename. I5 we created on ename. So I5 is the, for I5 it is showing normal index. This is also normal index only, but based on function we created. So that's why it is telling that function based normal. Lower of ename means this is function based index. Normal index can be also called as B-tree index. So this is function based B-tree index. So I6 is the function based index. Okay. One more. So if index is created based on function like this, we are calling this as the function based index. If index is created based on function like this, we are calling this as the function based index. Or if the index is created based on expression, If the index is created based on expression, then also it is called as the function based index only. For example, our frequent operation is, next one more example, another example. See, our frequent operation is retrieving data based on annual salary. For example, we are submitting query like this. Select employee number, e-name, comma, salary. Annual salary column is not there. We need to calculate that one. So how to calculate annual salary? Salary into 12. Salary into 12. We are giving alias name as annual salary. So we are giving an alias name as annual salary. From which table we are retrieving? From EMP table we are retrieving. So we want to retrieve the employee records whose annual salary is greater than 30,000. So where salary into 12 greater than 30,000 we are writing. So now observe here in the where condition. In the where condition, observe here, are we using any column? No, we are not using column here. Okay, in a where condition, are we using function here? No, we are not using function here. What we are using? Expression we are using. Based on expression we are retrieving. Salary into 12 is called expression. Based on the expression we are retrieving here. So on this expression, if we create the index, that is also called as function based index. So now, as of now, is it perform table scan or index scan? Table scan. Okay. Now, what I'm doing is on this salary to 12, I'm creating the index now. So create index. Index name I'm giving as I7 on EMP1. On EMP1. Okay. Salary into 12. On salary into 12 expression, we are creating this I7. So now index will be created. After creating the index, if we submit this query again, now is it perform table scan or index scan? Index scan, because index is created on salary into 12 expression. So this index is called function based index. So if index is created based on expression, or if index is created based on function, we are calling that as the function based index. So now I'm showing it. Observe. Our frequent operation is retrieving data based on annual salary. So we are writing like this. Select employee number, e-name, comma, salary, comma, salary into 12 as annual salary. As annual salary from EMP where salary into 12 greater than 30,000. So as of now, index is not created. So it performs table scan. Table scan it is performing. Okay. So let me open by using EMP1. Okay. So complete table scan it is performing. But we want to improve the performance. Our frequent operation is retrieving data based on this expression only. So what we are doing is we are creating one index here. So create index. Index name I am giving as I7 on EMP1 tables, salary into 12 column. On EMP1 tables, salary into 12. On salary into 12 expression, we are creating this index. So now index will be created. This index is called function based index. So now again we are submitting the query. Select employee name, employee number, employee name, salary. Annual salary we are calculating here. Salary into 12. Annual salary from EMP1 where salary into 12 greater than 30,000. Now already we created index on this expression. So that expression only we are using in the where condition. So it performs index scan. Observe. Index scan it is performing. That index name is I7. So this is the index created based on expression. Observe here. See. See here. I want to see the index information. So select index name, comma index type from user indexes. From user indexes. Okay, observe. Just now we created I7. Okay, this I7 created based on salary into 12. What it is telling, observe here, function based. Okay, this I6 we create on lower function, lower of fee name, it is telling that function based. So if index is created based on built-in function or expression, that we are calling as the function based. So this is about function based index. So B-tree index topic is over. So finally, now you know B-tree index very clearly. B-tree index means if B-tree is created, when we create the index, then it is called B-tree index. So then it is called B-tree index. If B-tree is created, that is called B-tree index. If B-tree is not created, okay, that is called bitmap index. So in the B-tree index, what are the subtypes? Simple index, composite index, unique index, and function based index. Unique index and function based index. So what is simple index? If index created on one column, if index is created on one column, we are calling that as the simple index. And what is composite index? If index is created on multiple columns, we are calling that as the composite index. Okay, what is the unique index? If index created on the column which is having unique values, the column which has unique values, that is called unique index. The index which is created on the column which has unique values, that is unique index. Function based index means if index created on built-in function, okay, or expression. If index is created based on function or expression, we are calling that as the function based. So these are the 4 B-tree indexes. So very clearly we have seen examples. Like on salary column, we are creating the index, that is simple index. On department number and job, we are creating the index, composite index. On department name of department table, we are creating the index, that is the unique index. Okay, we are creating the index on lower of a name. Okay, or we are creating the index on expression like salary into 12. These are function based indexes. So please confirm, is it clear till here? Okay, now see about bitmap index. Bitmap index. What is this bitmap index? Listen carefully. The name itself is giving the meaning. Bitmap index, it will not create the B-tree index, it stores the bits. Bit 0 is called a bit, 1 is called a bit. Bits will be stored in the bitmap index. So bitmap index means it will not create B-tree index. So if B-tree created, that is B-tree index. Here B-tree will not be created in the bitmap index. It will not create B-tree index. So what it stores? It stores, bitmap index stores bits. It stores the bits. Okay, what are the bits? Zeros and ones. So it stores the bits, zeros, those are zeros and ones. Okay, so zeros and ones will be stored here. So it stores the bits, zeros and ones. So every bit is associated with linked with one row ID. So here in the bitmap index, 1 will be stored. This 1 is connected with one row ID. So implicitly, this 1 will be converted to the row ID, and it goes to that row and picks the record. So that's why they have given name as bitmap. Here, this 1 is the bit. This bit is mapped with row ID. Map means link, connected. So bit is connected with row ID. Bit is mapped with row ID. Bit is linked with row ID. So this bit will be converted to the row ID, goes to that row and picks the record. So this bitmap index stores the bits. So every bit is in this. Every bit is associated with row ID. So this bit will be converted to the row ID. So this bit will be converted to row ID. Okay, and bit will be converted to the row ID. Okay, and picks the record. So it knows the row address now. So it goes to that row ID and picks the record. So bit will be converted to the row ID and picks the record here. Every bit is associated, or you can say linked, or you can say mapped. Every bit is mapped with row ID. So that's why we are calling this as bitmap index. Okay. So already B-tree index is there. Why we are using bitmap index, sir? On low cardinality columns, we create bitmap index. On low cardinality columns, we create bitmap index. On high cardinality columns, we create B-tree index. What is low cardinality column, sir? Low cardinality column means the column which is having less distinct values is called low cardinality column. So the column which is having less distinct values, is called low cardinality column. Low cardinality column. For example, less distinct values will be there. For example, there is a column. Okay, gender column is there. First employee gender is male. Second employee gender female. Next employee gender female. Next employee gender male. Next employee gender male. Next employee female. Next employee male. Next employee female. Female, male. Like this data is there. Now, in the gender column, gender values are there. Now you tell me how many distinct values are there in the gender column? 2. One is M and F. So can we say this as the low cardinality column? Yes, this is the low cardinality column. For example, I am taking employee number column here. Here I am taking employee number column. For every employee, how many employee numbers will be there? One employee number only. 1, 2, 3, 4, 1, 2, 3, 5. Okay. Or 1, 2, 3, 6. Okay. 1, 2, 3, 7. So like this, employee numbers are there. Okay. Like up to 1, 2, 5, 0. Okay. So like this. Okay. So these are the employee numbers. For example, assume that it is started from 1201. So 1202. So like this up to 1250 is there. So total 50 employees are there. Now how many distinct values are there? 50 distinct values are there. For every employee, one employee number is there. So how many distinct values are there? 50 distinct values are there. So less distinct values are there, more distinct values are there. more distinct values are there. So that is the high cardinality column. So gender is having how many distinct values? Male, F. Male, female. 2 distinct values. Okay. Whereas for employee number, how many distinct values are there? 50 distinct values. Okay. Here 2 distinct values. Male and female. Just 2 distinct values are there. So less distinct values are there means we call this as the low cardinality column. If high distinct values are there, we call that as the high cardinality column. Okay. For example, in our employee table, observe here, select star from EMP. In the EMP table, let me set the line size here. See, in the EMP table, total how many rows are there? 19 rows are there. Total 19 rows are there. Observe. I am writing like this. Select distinct. Total 19 rows are there. Select distinct department number from EMP. I am writing. So, how many department numbers it is giving? Observe here. Only 3. But in the table total, how many columns are there? 19 columns are there. So 19 rows are there. 19 rows are there. But how many departments are there? Only 3. How many distinct values are there? Only 3. So is department number low cardinality column or a high cardinality column? Low cardinality column, because less distinct values are there. 10, 20, 30. That's it. Okay. Among 19 rows, just only 3 distinct values are there. 10, 20, 30. So department number is the low cardinality column. Whereas if we take e-name, okay, maybe for some employees, for 4 or 5 employees, maybe same name may be there. Okay, sometimes it may be duplicated, but for e-name also, many distinct values will be there. For example, we are writing like this. Select distinct e-name from EMP. So many distinct values are there. 18 distinct values are there. Okay, so e-name is the high cardinality column. Department number is the low cardinality column. So what are the examples of low cardinality columns? So like low cardinality column examples are low cardinality columns. Examples are like gender, less distinct values will be there. Department number 10, 20, 30. Less distinct values will be there. Job also less distinct values will be there. So these are the low cardinality columns. High cardinality columns means more distinct values will be there. High cardinality columns means if a column has more distinct values, then it is called high cardinality column. High cardinality column. Examples are like employee number. Okay, e-name, salary, this kind of columns are the high cardinality columns. Gender, department number, job, this kind of columns are the low cardinality columns. So on low cardinality columns, so if a column has less distinct values, once again I'm writing, has less distinct values, then it is called low cardinality column. So on low cardinality columns, it's better to create bitmap index. On high cardinality columns, it's better to create B-tree index. So on low cardinality columns, we create bitmap index. On high cardinality columns, we create B-tree index. That's it. So what is bitmap index? It will not create the B-tree. What it stores? Bits, zeros and ones. So every bit will be linked with row ID. So this bit will be converted to the row ID and picks the record here. On low cardinality columns like gender, department number, job, we create the bitmap index. So low cardinality column means less distinct values will be there. High cardinality value means more distinct values will be there. So gender, department number, job are examples of low cardinality. Okay. Employee number, e-name, salary, these are the examples of high cardinality. On high cardinality columns, we create B-tree index. On low cardinality columns, we create bitmap index. So now we are creating one example on bitmap index. So we are creating one table here, one customer table we are creating. So create table. We want to create one customer table here. In the customer table, we want customer ID, customer name, and customer gender. Okay, we want to maintain like this. So create table. Table name is customer. First field is customer ID, number data type. Second field is CNAME, varchar2 data type. And third field is gender. Gender is the char data type. So like this, we are creating the table. So let me insert some records here. I'm inserting some records. Insert into table name is customer values. I'm giving values as 1A. M. So M means male. So female I'm giving, male I'm giving, female I'm giving. So this is 2B, 3C, okay, 4D, 5E, and 6F I'm giving. So to save this data, we are writing commit. Okay, so table is created. Table name is customer 1. So in that gender column is there. Our frequent operation is retrieving data based on genders. So female customers, okay, male customers. So like this, based on the gender, we are retrieving frequently. So to improve the performance, we want to create the index. So now in the gender column, less distinct values are there. Only male, female, 2 distinct values are there. It's better to create bitmap index. Okay. So as of now, we are writing like this. Select star from customer. Okay. Where gender equals to male, I'm writing. Where gender equals to male, I'm writing. Now, is it perform table scan or index scan? Table scan. Because till now, we didn't create any index. So it will perform table scan. So table scan, it is performing. Now, to improve the performance, we want to create the index. Here, less distinct values are there. So we want to create bitmap index now. We are writing like this. Create bitmap index. So create bitmap index. Bitmap index name I'm giving as BI1. On which we are creating, on which table we are creating customer. On which column we want to create gender. That's it. Very simple. So here we are writing this one extra. To create the bitmap index, right? Create bitmap index. Create bitmap index BI1 on which tables, which column. On which tables, which column we are creating this bitmap index, we are telling. So index is created now. If we submit this query again, now it will perform the index scan. Index scan will be performed. So this is about bitmap index. So if less distinct values are there, it's better to create this bitmap index. If more distinct values are there on high cardinality columns, create B-tree index. That's it. Now observe here. I am creating this table. I'm showing it practically. Observe. I'm copying all these queries. If any table is there with the name customer, I'm dropping that one. So new table we are creating. New customer table we are creating. And we are inserting 6 records. Observe here. See, here customer table created. CID, CNAME, gender. Next, we are inserting one record. One row created. Next, second row created. Okay, next third row created. Fourth row created. Fifth row created. Sixth row created. Total 6 rows are created and we committed the data. And see the table data. Select star from customer. So in the customer table, 6 records are there. Observe. So this is the data. Now, this gender is low cardinality column. Our frequent operation is retrieving data based on gender. We want to get in the customers. Some customers are males. Some customers are females. So we want to retrieve the data based on gender. So select star from customer where gender equals to M I am giving. So observe, is it perform table scan or index scan? Table scan. So table scan it is performing. Entire customer table accessed here. Now we improve the on we are giving. So what it is telling observe. So now bitmap index is created. We are submitting the same query on the gender. We are retrieving the data. Observe here, it is performing bitmap index. Based on the bitmap index, it is performing index scan. Based on the bitmap index, it is retrieving the data now. In the execution plan, clearly it is telling that, okay, using the bitmap index, it is converting the bits to the row IDs. It is converting bits to the row IDs. Every bit is associated with row ID. This one is associated with some row ID. Okay, another one is associated with some row ID. Like this, every bit is associated with the row ID. So using the bitmap index, bits will be converted to the row IDs. Now table is accessed by using that row ID. Okay, so using BI1, it is performing the index scan here. So this is bitmap index. So what is happening here? Try to understand. For example, in the table, gender column values I am giving. Okay, first customer male, next customer female, next customer female, next customer male, next customer male, next customer female, next customer male, next customer female, next customer male. Like this data is there. So when you create the bitmap index BI1, in the BI1, it stores in the bitmap index, it stores like this. M is one column now, F is another column now. M is one column, F is another column. Okay, please don't make noise. Okay, Babu, don't clap. See. So in the bitmap index, it stores like this. M1 column it will take, F8 column it will take. Because bitmap index means on less distinct values we created. So for every distinct value that creates one column. So in the gender column, 2 distinct values are there. M is one column, F is another column. Okay. First employee, male or female? Here, first employee, male or female? Male. Male means male value will be 1, female value will be 0. 1 means true, 0 means false. Okay, first employee male. So male value will be 1, female value will be 0. So 1 means is a male, 0 means is not female. Okay, 1 means true, 0 means false. So first person male, so M value will be 1, F value will be 0. Next, F value. Okay, second value is F. So F value will be 1, M value will be 0. Third employee. For third employee, okay, F value will be 1, M value will be 0. Next, fourth employee male, M value will be 1, M value will be 1. Okay, F value will be 0. Next employee also male. Okay, so M value will be 1, F value will be 0. Next employee female, so F value will be 1, F value will be 1, M value will be 0. Okay, next employee male, so M value will be 1, M value will be 1, F value will be 0. Next employee female, so F value will be 1, M value will be 0. Next employee male, so M value will be 1, F value will be 0. So like this, bitmap index will be created with bits, zeros and ones. Now we are retrieving data like this. Select star from customer where gender equals to male we are submitting. So we are writing like this, where gender equals to male we are submitting. So now what it checks now, male values it will check. So here what is the male value here? 1. This 1 will be converted to the row ID. This 1 will be converted to the row ID. So now it knows the row ID. It goes to that row and picks the record. Next, the checks once here because you are condition as what here z equals to M. If M value 1, that retrieves the record. And again here 1 is there. This 1 will be converted to the row ID. It goes to once again I'm repeating. Listen. To M. So M value 1 means male. Okay, M value 1 means male records. So here M value is 1. So this 1 will be converted to the row ID. So it goes to that row and picks the record. Zeros we don't want. Here this is 1. This 1 will be converted to the row ID. It goes to that row and picks the record. Okay. So here this 1 will be converted to row ID, goes to the row and picks the record. Okay, 0 we don't want. Next 1 will be converted to row ID, goes to the row and picks the record. 0 we don't want. 1 will be converted to row ID, goes to the row and picks the record. So like this, every bit is associated with the row ID. That bit in this way, it retrieves the data. Observe now here how many employees? Okay, 9 employees. Okay, 3. The 9 records are there. How many comparisons it is doing? Please confirm. How many comparisons it is doing? 9 comparisons it is doing. In table scan also it will do 9 comparisons only. Okay. Here also in bitmap index also it is 9 comparisons, right? If B tree is created, that goes to right part or left part based on greater, less than or equals to. That goes to the left part or right part. Half of the comparisons it will done. But here in bitmap index, if 9 records are there, 9 comparisons it is doing. In the table scan also, if 9 records are there, 9 comparisons that will do. Bitmap index is also doing same number of comparisons. Then how bitmap index is improving the performance? Like this interviewer may ask. See, number of comparisons is equals to number of records in table scan. Okay, so number of comparisons is equals to number of records in table scan. In bitmap index also, number of comparisons is equals to, okay, number of records in bitmap index scan also, in bitmap index scan. Then how bitmap index improves the performance? How bitmap index improves the performance? So like this, if anyone is asking, simply you can say single point here, that is, okay, in case of, for example, if that is performing table scan, if that is performing table scan, in table scan, what it will compare, whether this F value equals to M or not, it will compare. So it comparing with the value or bit value. In table scan, it compares with the value. Try to understand. First value is what here? This condition we are writing. In table scan, what is happening? I am explaining now. What is the first customer gender male? So is M equals to M or not? It is checking. Okay, here is F equals to M or not? It is checking. Is F equals to M or not? Okay, is it value comparison or bit comparison? This is value comparison. Where if you take bitmap index here, okay, see here male value is 1 or not, it is checking. Male value 1 or not, it is checking. This A column value, okay, 1 or not, it is checking. So is it this is bit comparison. This bit comparison is faster. So bit comparison is faster than value comparison. That's why it improves the performance. This is the answer. So in table scan, value comparison it will do. In bitmap scan, bit comparison it will do. So bit comparison is faster than Bit comparison is faster than value comparison. So it improves the performance. So bit comparison is faster than value comparison. So bitmap index improves the bitmap index scan improves the performance. Number of comparisons same, but this bit comparison is faster. Okay, so maybe network problem is there. Online students, maybe network problem is there today. Maybe internet speed is slow. Please adjust for the session. Okay. So bit comparison is faster than value comparison. So bitmap index can improve the performance. This is the answer. So in table scan, number of comparison equals to number of records. In bitmap scan also, number of comparisons equals to number of records. So how it is improving the performance means bit comparison is faster than value comparison. In table scan, that performs value comparison. In bitmap scan, that performs bit comparison. So bit comparison is faster than value comparison. So this is about B tree index and bitmap index. So sometimes interviewer may ask like this: what are the differences between B-tree index and bitmap index? You already know all points. Just all points I'm writing at one place. So left side I'm writing points on B-tree index. Right side I'm writing points on bitmap index. So differences between B-tree index and bitmap index. So in B-tree index, okay, is it create B-tree or not? Yes. So in this B-tree will be created. B-tree will be created. Whereas in bitmap index, is it create the B-tree? No. In this B-tree will not be created. B-tree will not be created. Okay. So what this B-tree index stores in the leaf nodes, it stores value and row ID. For example, 3000 salary is row ID. Okay. 2000, 5000 salary is row ID. Like this. 4500 salary, row ID. So like this, value and row ID will be stored in the B-tree index. So B-tree index stores. So in this, value and row ID will be stored. Value and row ID will be stored. Value and row ID will be stored. Whereas here, in this, in bitmap index, what it will be stored, what it stores in this, only bits will be stored. Bits will be stored. Zeros and ones. So in this, only bits will be stored, zeros and ones will be stored. So only zeros and ones will be stored here. So B-tree index stores value and row ID. Bitmap index stores zeros and ones. Okay. And so it stores the bits. Every bit will be associated with, every bit will be mapped with, every bit will be mapped with row ID. So this bit will be converted to row ID and picks the record. This bit will be converted to and picks the record. Converted to the row IDs and picks the records here. So whereas in the B-tree index, direct row IDs are stored there. Values and row IDs are stored. But whereas in bitmap index, bits are stored. Every bit is associated with some row ID. That bit will be converted to row ID and picks the record. So when we create this B-tree index on high cardinality columns, create B-tree index. On high cardinality columns, create B-tree index. On low cardinality columns, create bitmap index. So on high cardinality columns, create B-tree index. On low cardinality columns, create bitmap index. So what are the examples of high cardinality columns? Like employee number, okay, e-name, salary. These are the examples of high cardinality columns. What are the examples of low cardinality columns? Like gender, department number, job. These are the low cardinality columns. So on high cardinality columns, create B-tree index. On low cardinality columns, create bitmap index. That's it. These are the differences. So in B-tree index, B-tree will be created. In bitmap index, B-tree will not be created. In the B-tree index, values and row IDs will be stored. In bitmap index, zeros and ones will be stored. On high cardinality columns, we create B-tree index. On low cardinality columns, we create bitmap index. Next, finally, See, next, sometimes interviewer may ask like this. So when we drop the table, does it drop rows and columns? Yes. Table means what? Table means rows and columns only. So table means rows and columns only. So when we drop the table, okay, does it drop rows and columns? The answer is yes. Okay. When we drop the table, does it drop the view? In the previous session we discussed. No. If we drop the table, does it drop the view? No. Okay. Even if view is created based on table, view will not be dropped. Okay. So in the same way, when we drop the table, does it drop the index? Okay. So when we drop the table, does it drop the index? The answer is yes. If table is dropped, automatically indexes created on that table also drop. For example, you already know how to see the index information. I'm setting auto trace value as off. Set auto trace off. Okay. How to see index information? All So there is a system defines. It maintains all indexes information. If we want to see the index information, what we write here? Select index name, comma, index type. Index type from user indexes. Like this we write. Okay, observe here. I'm running this one. See. Okay, so let me set the line size as 50 here. Okay, observe. Just now we created BI1. Which type? Bitmap index. BI1 is the bitmap index. This is index name. This is the index type. BI1 is the index name. Bitmap is the index type. I7 we created on salary into 12. So it is created based on expression function based on normal index means B3 index. Okay, I6 we created on lawyer of fee name. So function based on normal index. Okay. So B3 index can be also called as normal index. So one is normal index, another one is bitmap index. Observe here. Here index type is bitmap. Here index type is normal. Normal means B3 index. Bitmap means bitmap index. So how many types of indexes are there? 2 types. So one is bitmap, another one is normal. Normal index can be also called as B3 index. So till now we created these many indexes. Okay. So most of the indexes we created on EMP1. So how many indexes are there? Observe. How many indexes are there? Sorry. How many indexes are there? 12 indexes are there. How many indexes are there? 12 indexes are there. Observe here. Here this BI1 is the bitmap index. Okay. So I7, I6 are the function based B3 indexes. These are the B3 indexes only. Normal index means B3 indexes. So there are 2 types of indexes, B3 index, bitmap index. So B3 index can be also called as normal index. So total how many indexes are there? 12. So now I'm dropping one table here. Most of the indexes we created based on EMP1. I am dropping this EMP1 table. Now some indexes will be dropped here. Observe. Select index name, comma index type from user indexes. How many indexes are selected now? 8. 4 indexes dropped here. When we drop this EMP1 table, here 4 indexes are dropped. Okay, with this we can understand that if we drop the table, does it drop the indexes created? Yes. Okay, if anyone is asking, when we drop the table, does it drop the indexes created on it? Means yes. all indexes information stored in the user indexes. There you can check index dropped or not. And finally, dropping the index. Dropping index. So to drop the index, we write drop index name. This is the syntax. Drop index name. This syntax we have to follow. And example is drop index I1 I am giving. So now I1 index will be dropped now. Observe. So as of now, I1 index is there. So select, drop index I1. So I1 index we are dropping. Okay, now observe here in the index list, there is no I1 now. I1 dropped here. Observe, I1 is not there. Only 7 are there. I1 is not there. So with this, we can understand that drop index I1 means I1 is dropped here. So this is dropping indexes, and this is about index topic. Index topic is over. So final overview on index I am giving. See, index purpose is what? Improves the performance of data retrieval. So to improve the performance of data retrieval, we use this index concept. This is the only advantage we are getting. And next, types of indexes. How many types are there? 2 types. What are those? B-tree index and bitmap index. In the B-tree index, again subtypes are there. What are those? Simple index. Simple index means index created based on one column. Next, composite index. Composite index means index created on multiple columns. Okay. Next one is unique index. Unique index means index created on unique column. Okay. A column which has unique values. A column which has unique values. On this we create it. Okay. And function based index means if index is created based on function like lower function, upper function, init cap function, based on function or expression. So if the index is created based on function or expression, that is the function based index. So in all B-tree indexes, implicitly B-tree will be created. So whereas this bitmap index stores what? Zeros and ones. Okay. Whereas B-tree index stores what? Value and row ID. Okay. Values and row IDs will be stored. Values and row IDs. So in bitmap index, only zeros and ones will be stored. So these bits will be associated with the row IDs. So every bit will be converted to row ID and picks the record. So on low cardinality columns, we create it. On low cardinality columns, we create it. On high cardinality columns, we create the bit tree. So low cardinality column means less distinct values. High cardinality column means more distinct values. Okay, so like e-name, salary, these are the high cardinality columns. Low cardinality columns means like gender, department number, okay, etc. So this is overview on indexes. Index topic is over. So please confirm, is it clear about index? So in the interview purpose, after focusing on table, if interviewer want to test on other database object, he focuses on view and index. View and index are also important. Okay, I'm stopping the session here. On Monday, we discuss another database object sequence. Okay, thank you everyone. See you on Monday.